Today we're going to be discussing how we find unit rates from graphs and how tables, unit rates, graphs, and equations all fit together. Now before we get started, we're going to talk a little bit about our coordinate plane. So remember that our coordinate plane is where we plot points. And to graph on a coordinate plane, our x value is always going to tell us how much we move left or right. And that's because our x-axis is our horizontal axis on our graph. And y is always going to tell us how much we move up or down because it represents, it's our vertical axis, so it represents the points on, it represents the points going either up or down. Okay. So we're going to start with this first example. When we do problems, we start off by taking our table and then graphing our points. So first point I see here is 0, 0. So I'm going to plot that right at the origin, at the point where both of our axes meet. Now 1, 2, 1 tells me that on my x-axis I'm going to go to 1, on my y-axis I'm going to go to 2, and just like in Battleship, you figure out where both of those meet and you plot your point. Next one we have 2 and 4, so I go to 2 on my x-axis, I go to 4 on my y-axis, and this is where they're going to meet up. And last but not least, 3 and 6 will meet up right here. Now last thing that we want to do is connect our lines. So I'm going to connect all the way through my points until I get to the origin. I stop right there. And then I want to show that this pattern could keep on going on forever. So I'm going to draw an arrow. Notice with my graph that I extended my line all the way across the graph and I drew my arrow and I stopped at the origin. Now the next couple of things that we're going to do is find the unit rate and then find our equation. So before we talk about how that looks on our graph, remember that yesterday we talked about how to find that from a table. So yesterday we talked about how to find k, our unit rate. We can take y divided by x, so in this case 2 divided by 1, and 2 divided by 1 is going to give me 2. Now I could do the same thing all the way through my table. 4 divided by 2 gives me 2. 6 divided by 3 gives me 2. And so I see that my unit rate is 2. And then just like we talked about yesterday, when we write our equation, it's going to be y equals my unit rate k times x. And so that means I'm going to put y equals 2x. Now the reason why we do that is because that equation tells me that for any value of x, I multiply it by 2 to get y. So 0 times 2 gives me 0. 1 times 2 gives me 2. 2 times 2 gives me 4, and so on. So my equation is y equals 2x. Now let's look at the next one. So I'm looking at a number of tickets versus a total cost. Now notice that some of my numbers are a little bit bigger, and so they wouldn't all fit on the graph. Now I have to start with my origin at 0, 0. So I am going to put 0 where my x and y axis meet, but then for my x-axis, which I'm going to consider in this case the number of tickets n, I'm going to put the numbers 2, 4, 6, and 8. And then I can also fit 10 on there if you want to do that. And then the total cost, notice that that's going up by 15. So I'm going to count by 15s on my y-axis, or in this case, we could call it our c-axis. So we have 15, 30, 45, 60, and if you wanted to fit the last one in there, you could put 75. Now I want to plot my points. So I see that my first point is at 2, 15. So where 2 and 15 meet up, I plot my point. Then where 4 and 30 meet up, I put my next point, and so on. So I see that my point's going to go right across my graph. If I wanted to predict the next one, it would go at 1075. And then I connect those and draw an arrow. And then I need to find my unit rate. Now notice that this is a straight line. They're going up at a consistent rate. And you're going to notice that both of these lines for problems 1 and 2 go through the origin. And so we can say that this is a proportional graph. So since it's proportional, if I take the y divided by the x, I'll get the same thing all the way through. Now if I take 15 divided by 2, that gives me 7.5. So my unit rate is 7.5, and my equation is going to be y equals 7.5x, or if you want to use the numbers that we have, or the letters that we have here, n and c, you would say that c equals 7.5n. And the reason why that is because if I were to take 7.5 times my number of tickets, I'm going to get the total cost. Now something else that you can recognize is that 7.5 has to be the cost of a ticket because it makes sense for us to take the number of tickets times that to get the total cost. Now 7.5 would be the same thing as $7.50, so it's $7.50 per ticket. Now notice, like we said before, that the two things that we have in common between these graphs is that they both start at the origin and they make a straight line. And so when we identify the unit rate and write our proportional equation, these are only going to work if x and y are proportional. And the two things that have to be true of your graph if it's proportional is that the line has to be straight. That means it's going up at a consistent rate, and it has to go through the origin, because anytime that we have a proportional relationship, our very first value should be 0, 0. For instance, if I relate tickets to cost, if I have 0 tickets, the cost should be $0. And so it always has to go through not the original, the origin. Now next what we're going to look at is finding the equation and unit rate from the graph. So we are still going to look at the table, but we're going to talk about how you could just identify it straight from the graph. So first example says Sandra is making trail mix. The graph shows how many cups of nuts she uses compared to the number of cups of dried fruit. Answer the questions and fill in the table. So first thing we're going to do is go ahead and fill in our table. So I just want to look for my points. So my very first point, I see my x value is 1, my y value is 2, so it's 1, 2. Next point that I get to is at 2, 4. The next point I see is at 3, 6. And then last but not least, 4, 8. Now you should notice that our y values are twice as big as the x values. And so that actually shows me that my unit rate is 2. Now if I wanted to try to find that, I can choose any ordered pair that I want to find k, take y divided by x. So for instance, if I use 4, 8, I would take 8 divided by 4 and get 2 as my answer. Now looking at our graph, we can actually find this ordered pair. Now before we get there, let's talk about what this unit rate represents. So notice that I'm taking y divided by x here. Now on our y-axis we have cups of fruit, on our x-axis we have cups of nuts. And so for the trail mix, that means that I'm going to have 2 cups of fruit for 1 cup of nuts, or per cup of nuts. Now if we think about which point on our graph represents this, since this per cup of nuts means for 1 cup of nuts, I see that I have 1 cup of nuts here where I have 2 cups of fruit. So we consider this our unit rate point, our unit rate ordered pair. And so our ordered pair here is going to be 1, 2 that represents the unit rate, where our unit rate ends up being the y value. Now the reason why this happens is because whenever we read our unit rate, it's always y per x. So cups of fruit per cups of nuts. And so the 4, 1 is going to be the amount that's on the y-axis. And so when we try to identify our unit rate ordered pair, it's always going to be our point that's at 1, k. So instead of actually using your table to come up with your unit rate, now you have another way. You can look for where your graph is at 1 on your x-axis, where your line hits 1 on your x-axis, which is going to be in this case 1, 2. Now that means that if our unit rate is 2, that our equation is y equals 2x, which makes sense because if I were to multiply any of these x values by 2, I would get my corresponding y value. Now last but not least, it asks the question, what does the point 2, 4 represent? Now looking at your graph, that means that we have 2 cups of nuts for 4 cups of fruit. So the 2 represents the amount of nuts, the 4 represents the amount of cups of fruit. So 2 cups of nuts for 4 cups of fruit. Okay, so let's move on to the next one. So the next one says, the graph shows the relationship between the pounds of cheese bought at a deli and the total cost in dollars for the cheese. Okay, so first thing we want to do is identify some points for our table. So I'm going to start with the first one at 0, 0. Might as well. And next I can see that I have a nice point at 1, 4. Then also at 2, 8. And then last but not least, I could also use 2.5, 10. So anywhere where it hits a nice grid line, that's a good choice to use. Now remember from before we talked about we could find our unit rate by finding 1 on our x-axis and seeing where it meets on our graph. And so 1, 4 would be our unit rate point, which means that 4 is our unit rate. Now again, you could find it by taking, for instance, 8 divided by 2 or 10 divided by 2.5. But using your table is another way to find that. So the ordered pair that represents that is 1, 4. Now this unit rate, remember we did y divided by x, so cost divided by pounds. So our unit rate represents that it costs $4 per pound of cheese. Now we also need our equation. Remember equation, we just plug in our unit rate in the equation y equals kx, so that means it's going to be y equals 4x. And then last but not least, it says how many pounds did Erica buy if they spent $12? Now notice that we don't have $12 on our graph, so we want to figure out another way to solve this. Now remember that our cost is y, so what I can do is replace y in my equation with 12 and then solve for x. So to get x by itself, I would divide both sides by 4, and that tells me that x is going to be 3. So Erica bought 3 pounds. Now another way to do that, you can think about how each of your pounds you multiply by 4 to get the cost. That's telling you that it's $4 per pound. So if you spent $12, that means that you would have bought 3 pounds because 12 divided by 4 gives you 3. Now let's move on to the next page. So next page again, we're going to be graphing from an equation. Now if we're ever given an equation, what we can do is start off by using this equation to come up with our ordered pairs. Now I'm just going to choose some nice values for x, so I'm going to choose 0, 1, 2, and 3. And then I'm going to think about what y would be if y equals 3 times x. So when x is 0, that means I'm going to take 3 times x to 3 times 0, and that's going to give me a y value of 0. When x is 1, I'm going to take 3 times 1, and that's going to give me a value of 3. When x is 2, 3 times 2 gives me a value of 6, and last but not least, 3x, 3 times 3 gives me a value of 6. Or, sorry, just kidding, of 9. Now when I graph it, I can kind of space things out as far as I want to. I think since I'm going up to 9 on my y-axis and I'm going to up to 3 on my x-axis, I'm just going to go up by 1s on my x-axis. If you wanted to, you could space apart these values a little bit further. You could space them, maybe put at your second mark, you could put 1, and your fourth mark, you could put 2. But I'm just going to space it out like this. Now on my y-axis, I have to get up to 9, so I would say again, just going up by 1s would be fine. So I always need to label my x and y axis. I'm going to stop right here, and then I just plot my points. So 0, 0, 1, 3, 2, 6, and then last but not least, 3, 9. Now after I finish that, I need to connect my points, and remember that I connect all the way across the graph and draw an arrow at the end showing that pattern keeps on going. And remember that I can find my unit rate for where x is 1. So x is 1 where y is 3, so that means my unit rate is 3. I could also do that by taking y divided by x for any point. And I see that this is a proportional graph because it started at 0, 0 and it went through the origin, so yes, it is proportional. Now the next one we have y equals 1/3 x. So I'm going to, again, just use values for x. This time, I think I'm going to go up by 3s, and the reason why is because I see that I'm going to be multiplying x by 1/3, so I want to have kind of nice answers. So I'm just going to choose 0, 3, 6, and 9 for my x values. So again, I'm going to take 1/3 times my x, so 1/3 times 0 gives me 0. 3 times 1/3 would be 3 over 1 times 1/3, which would end up giving me 3 over 3, or 1. 1/3 times 6 I could take 6 over 1 times 1/3, and when everything cancels out, that'd leave me with 2, and